In the final chapters of Extending Children's Mathematics, Fractions and Decimals, explore methods for heightening student understanding of decimals and implementing operations on fractions and decimals. In their chapter on decimals, Empson and Levi advocate scaffolding instruction based on student understanding of base 10 number concepts. It is important for children in younger grades to begin by understanding how numbers can be composed by groups of 10. I have seen this emphasized in my school's kindergarten by having the students count the number of days they are in school using straws. Each day at the morning meeting, the teacher adds a straw to the pile. When the number of straws reaches 10, the straws are bundled together. As the days progress, the students count mostly by tens, and this seems to be an effective strategy. Once you are able to gauge student understanding, create small groups for differentiated instruction. The text provides the example of Miss Andrews' classroom, which is composed of both 4th and 5th grade students. As with many classrooms, the students are at varying levels of understanding. Empson and Levi stress the importance of offering conceptual tasks to gauge understanding rather than specific procedures such as moving a decimal point to divide. Miss Andrews uses multiple groups problems of varying levels of sophistication to build her students' understanding. Once she feels secure that the students are ready to progress, she introduces open number sentences such as 50 plus b equals 75. As teaching progresses, they come to open number sentences with multiple answers, such as a times 10 plus b equals 87. Once students have grasped this concept, Miss Andrews begins to introduce decimal notation by explaining how fractions with a denominator of 10 can be written with a decimal point. Following this, students in her class are easily ready to move on to addition and subtraction involving decimals. Miss Andrews sees a stark advancement in student understanding as she layers out her unit on decimals over 6 weeks' time. Students in each of her small groups have progressed substantially, and many have moved between groups. Building the foundation of base 10 concepts leads to greater ability in using decimals and fractions. In Chapter 8, Empson and Levi explore strategies for the use of operations with fractions and decimals. In Chapter 7, we see how to lead children to understand addition and subtraction with like denominators. For problems with unlike denominators, they suggest a sequencing problems to extend student understanding. In the example of Miss Lewis's class, she begins with the problem, 2 people want to share 1 3/4 submarine sandwiches, so that each gets the same amount. How much should each person get? Then advances difficulty as students progress towards multiplication. The sequence for multiplication begins with the problem, Bella loves to read graphic novels. She got 12 graphic novels for her birthday. She has to read blank of the books. How many has she read so far? The teacher allows for the students to choose between 3 options for the multiplier in this problem, so they may challenge themselves at the level they deem appropriate and advance at their own pace. This strategy is replicated for division problems as well. As I come to the conclusion of Extending Children's Mathematics, I'm impressed with the amount of information provided in the text. The examples of students' work and classroom observations provide real-life relatable examples of implementing relational math in primary grades. It is a resource I am sure to use often as I continue my teaching career.